Okay guys, now that we've applied all of our loading conditions, we can go to solving. So we select solution, solve, current loading system, select OK. If everything's okay, then you should be getting this notice, solution is done. We'll close that and we'll exit the status command. And now we can go about extracting results. So we'll go to General Post-Processor. You have multiple options. You can go to Plot Results, Deformed Shape, Deform plus Undeformed, just to see the plot, how this beam will deflect. We can go to Contour Plot Nodal Solution, select Degree of Freedom Solution, and the Y component of displacement. So this will plot the Y displacement and show us where our maximum and our minimum displacements are. But we want to try and list our results in an element table so that we can extract the maximum bending moment and the maximum bending stresses. Okay, so to do that, we will first go to list results. Not list results, sorry. Read results. We'll select last set. And then we'll go to element table. Define table. We'll add a table. Now on the left hand side, we'll select by sequence number. And we will enter our SMISC numbers. Now each one of these has a sequence number. If you search again beam 189 output results, it'll give you the table and what SMISC code number represents what result you'll be extracting. Okay, so in our case we'll enter 3, click apply, and again SMISC 16, apply. 6, apply. 19, apply. SMISC 32, apply. Finally, SMISC 33, and after that we'll click OK. Now what each one of these represents is 3 and 16 will represent the bending moment about the Z direction, about the Z axis. 6 and 19 will represent the shear forces in the Y direction. 32 and 33 will show you bending stresses. Okay, so if we plot 3 and 16 together, that will show us our bending moment diagram. 6 and 19 together will represent our shear force diagram, and 32 and 33 will show us our maximum bending stress and minimum bending stress, or maximum compressive and maximum tensile compressive stresses. Once we've done that, we click close. Now we'll go to plot results, contour plot, 9 element results. And we will plot our bending moments, so SMIS 3 and SMIS 16. We'll click OK. And this is our bending moment diagram. Please note our maximum bending moment is 981,257 Newton meters. And it's occurring at element 30. We can also plot our shear stress by selecting SMIS 6 and SMIS 19. And this is our shear force diagram. Now we can list our elements and their results. So we'll go to element table, list element table, and we want to see the shear stresses. So we will select 32 and 33. Click OK. And this gives us the maximum compressive and maximum tensile stress in each element. And right at the bottom will show us our maximum stresses. So our minimum stress values occur in element 122 and 31. These values, and the maximum 31 and 122 at these values. Notice that the maximum bending and tensile is going to be equal as well to the compressive. Shows us that our neutral axis is running right through the center of the geometry of our cross section, which is what we are expecting. Now, with regards to the lab handout, we have to try and make the comparison and find our loading factor. And our loading factor is equal to a loading factor. In this case, you can use the formula right at the bottom. So maximum bending moment is our phi times our force y times z, which will give us this value. And we're going to divide this by our maximum bending moment. Remember that our maximum bending moment is found by plotting SMIS3 and SMIS16. Our maximum bending moment is (918,257). So we will divide 601,650 divided by 981,257, and we will get our loading factor. Thank you very much for listening. I hope this video was informative. Please be reminded that your lab report will be due next week. In it, you will describe all of the steps that we've taken. You will clearly explain why each step was performed the way it was, and explain the importance of loading factors. Naka.